So here in the read over, if you're doing such as water, in parentheses, this is just the formula for water. So a chemist would read this as water, but you could say or H2O and carbon dioxide or CO2. Then down here we look at NaCl, sodium chloride. I've added what's in highlight here to help the read over. Contains one Na plus or sodium cation for each Cl minus chloride anion. Although there are trillions and trillions and trillions of sodium cations and chloride anions stuck together. So again, I've added these to help with the read over. So trillions of Na plus or sodium cations and Cl minus chloride anions stuck together in even the smallest crystal of NaCl, sodium chloride, or table salt. And this site shows a graphic of the ionic structure of sodium chloride. And then at the bottom of page 10, you can recognize an acid because its formula usually begins with an H, hydrogen. Water is an exception to this rule. On these self-assessments here on page 11, a chemist would actually read the formulas of these, but I think it is, I think it's okay just to say NaCl because we're just looking at whether these elements are metals or nonmetals, not so much focusing on the naming. The naming of them is different. For example, I don't want to get into it. So I think for this you can just say NaCl, capital C, capital O, capital C, lowercase o, I2, capital I, capital F3, capital K, capital F. And then down here, capital K to capital S, capital O, for capital H to capital S, capital O for capital C, capital H for capital H, then capital C, lowercase l, HCl, capital M, lowercase n, capital C, lowercase l, 2. If you do want to say the names, I'll just go ahead and say the names here if you want to use those. This is sodium chloride, this is carbon monoxide, this is cobalt 2 iodide, iodine trifluoride, potassium fluoride. This is potassium sulfate, sulfuric acid, methane, hydrochloric acid, manganese 2 chloride. Yeah, so you wouldn't want to say the name before they actually do it because both of the acids have acid in their names, so you would have to, I think it's better just to say the H2SO4 and still emphasizing which letters are capital and which ones aren't. Okay, down here you can just say Na plus and Br minus form NaBr, while Ca2 plus and CO32 minus form CaCO3. But again, it's probably best if you say capital Ca, lowercase a, capital C, capital O, subscript 3. I'll really leave that up to you. If you feel like it's too cumbersome, as I said before, you can maybe ignore that, but it is really important that students recognize the difference between the capital and the lowercase letter. So I'll just leave it at that. So let's see, consider the aluminum cation and the sulfide anion, which have charges of +3 and -2 respectively. The charges would not cancel out. So we'd say Al +3, S -2. And then as you're reading these, you can just say Al3 plus cation, Al3 plus cation, S2 minus. Again, I'm not really sure how often to really emphasize the capital versus the lowercase, so maybe you can just say it one time as you read something the first time, and then after that maybe ignore it, just say the letters as they exist. One thing that is important is up here, this is not an I, this is a lowercase l, and that's a lowercase l as well. This is an I, so that's a little bit confusing, but you have to identify that. Capital I, lowercase l, lowercase l. And here we are, I think on page 12, yeah. So in this example, you just say Ti +4, O2 minus, Ti2, O4, and that would reduce to TiO2 again, maybe at one point, the first time you mention it, capital T, lowercase I. So here's potassium and sulfide, potassium plus, S2 minus. I think these are pretty straightforward down here. And down here, you just say Na2O, capital C, A3, capital N, 2, capital B, lowercase a, capital C, lowercase l2. This is an L here, not an I. Chloride is C, capital C, lowercase l. So down here, sodium nitrate would go to capital N, lowercase a, capital N, capital O3. Sodium phosphate, capital Na plus, capital P, capital O, 4, 3 minus, goes to Na3, PO4. Aluminum and sulfate, Al plus 3, SO4, 2 minus, goes to Al2, parentheses, SO4, end of parentheses, 3. And then calcium and hydroxide, Ca plus 2, OH minus, Ca, OH2. And another thing you could do is, as you're reading these, you could at the very beginning say, I'm not going to differentiate between capital and lowercase letters. You can just say that, but it is really, really important that you write the capital letter where it's required and the lowercase where it's required. So you could get out of the cumbersome nature of having to specify capital and lowercase by just announcing it at the very beginning. Alright, let's see. So down here on page 13 we have how we write out the cations using Roman numerals. And so again, the way that it's written would be iron with the Roman numeral in parentheses 2, but we would just say iron 2. So the point of this is to actually students to make the connection between this charge that's written in as a superscript to the way that it's actually written in a name. So here you can just specify iron parentheses Roman numeral 2 end of parentheses, and copper, the plus 1 is copper parentheses 1 end of parentheses. So on what page are we on? Page 14, iron 2 phosphide, you can just say Fe3P2, copper 1 sulfide, Cu2S, gold 3 oxide, iron 2 sulfate, chromium 5 carbonate, and then down here are the answers: Au2, O3, FeSO4, Cr2, CO3, 5. And then here we're looking at some practice of naming. So you can just, at this formula, just say TiCO3 and then titanium carbonate. Ask yourself if it has a variable charge. And then here you can just read out the symbols Al, Zn, Ag. This is a lowercase l for aluminum, not an I. Let's see. So you would read this, titanium 2. And again, so to help with the read over, I've just added here the Roman numeral indicates the charge because that's a really important part of it. Even though I say it down here again, I think it'll just help with the read over. So this next example, you can just say FeO, VO2, AuPO4, Fe2O3, parentheses NH4, end of parentheses 2, SO4, NaCl, Ca, parentheses NO3, end of parentheses 2, Ba, parentheses OH, parentheses 2. And then down here, everything in parentheses is going to be a Roman numeral. So iron 2 oxide, vanadium 4 oxide, gold 1 phosphate, iron 3 oxide, ammonium sulfate, sodium chloride, calcium nitrate, barium hydroxide. Again, this right here, this is a Cl, not a Ci. And then here on page 15, binary acids are made of, I put the symbol here, but you can just read the hydrogen. I added that to the notes, and one other element. And these names here, hydrofluoric acid, hydrochloric acid, again this is an L, not an I, hydrobromic acid, and hydroiodic acid, and this is an I. So HI is hydroiodic acid, and HCl, hydrochloric acid. So here on page 16, CO3 2 minus carbonate, or carbonic acid is H2CO3, 2 minus is nitrite, nitrous acid, HNO2. This is an L here, not an I. ClO minus, hypochlorite, hypochlorous acid, HClO. And then here on page 16 we can say such as water, H2O, ammonia, NH3, and hydrogen peroxide, H2O2. And on the end of page 16 and beginning of page 17 you can say, for example, CO is carbon monoxide, not monoxide, and N2O5 is dinitrogen pentoxide, not pentaoxide. And then these just are read just the way they sound: mono, di, tri, tetra. It's